Hello everyone, and welcome to our 11.5B volume of prisms and cylinders notes. So the first thing I want you to recognize is that we are now on to volume. Remember that volume is going to be measured in units cubed. So surface area was going to be looking at the amount of material that it took to build the shape. So that's like the walls and the bases of the figure. This is going to be the amount of space on the inside of these polyhedrons. And so volume is going to be the number of non-overlapping cubic units contained within a figure. And today we're going to focus on finding the volume of prisms and cylinders. And so my volume formula is going to be the area of the base times the height, B times H. And so this is a little bit different than what you did in middle school, because in middle school you just did length times width times height, because you only really looked at rectangular prisms. But we're going to be looking at triangular prisms, trapezoidal prisms, pentagonal prisms. So this formula works for all. So we're going to be doing B times H, and then same thing for a cylinder, except for that the base is always going to be the same shape. So prisms can have different kinds of bases: rectangular, triangular, pentagonal, hexagonal, all different numbers of sides, because these are polygons. So they have many types of different sides, whereas in a circle, it's always going, or in a cylinder, it's always going to be a circle. So when you find the area of this base, it's always going to be pi r squared. So what do we get to fill in for a cylinder that we don't get to fill in for a prism? It's going to be pi r squared times the height every single time, because that's always going to be a circle. So it's still base times height. It's just that that's always, always, always a circle. Okay. So what we're going to be doing is we're going to be taking the area of the base and we're going to be multiplying it by the height between the bases. So when we say B, that is going to stand for the base area. So it's not just a random number on the base, it's going to be the area of whatever the base is. The H is going to stand for the height between the bases. So make a note of that. So like we said, we're going to be giving you the formula on test day, but you have to know how to apply the formula. H doesn't just stand for a height. There could be multiple heights on a diagram. It's going to stand for the height that exists between the bases. So from this circle, the top of this circle to the top at the right of the circle to the top right at the bottom of the circle is going to be a height between those two bases. Same thing here. The top right of this four-sided figure to the top right of the other base is going to be a height. Okay, so it says solve for the volume of each figure. For prisms, round the answers to the nearest tenth. For cylinders, we're going to leave them in terms of pi. For composite figures, round final answers to the nearest tenth. We don't have any composite figures on this one. We will get to those later on. Okay, so if you were in middle school, you would have looked at this picture and you would have said, okay, it's length times width times height. So you would have said 24 centimeters times 20 centimeters times 10 centimeters. And when you do that, you would get 4,800. And in middle school, y'all did the units as well. You said centimeters cubed, and that is absolutely accurate, and nothing is changing from that. We just need a formula that works for all prisms, not just rectangular and square prisms. And so let's look at how that compares to what's new this year. There's a base that's parallel to this base. So we know we have multiple in rectangles. We have multiple sets of parallel bases, but I'm going to be working with these two. So I'm going to color it in. So using our new formula, it's going to be equal to volume equals base times height. Area of the base times your height. So what is my base? What is the shape of this base? Well, this is a rectangular, so let's go ahead and name that. It's a rectangular prism, so y'all go ahead and write that down. That's the first thing that you need to ask yourself, is what kind of shape is it? The volume for a prism is base times height. So how do we find the volume of the shape? Well, we want to find the area of that base. So it's not 24, it's not 20, but we do use those numbers in order to find the area of that shape. So 24 times 20, that length times that width, is what gives me 480 centimeters squared of space. So that's going to be 480 centimeters squared. 480 is that 2D shape. And we want to multiply that by the height. Well, what is our height between our bases? That is going to be from the bottom floor to the top floor. That is going to be 10 centimeters between those two. So that's going to be times 10 centimeters. So where do we get to the third power? Centimeters squared times centimeters to the first power. Exponent rules tell us to add those. So our total volume in the shape, when you multiply those out, base times height, is 4,800 centimeters cubed. So we still get the same thing that we would have gotten in middle school. We're just going to use a formula that works for all prisms, not just rectangular ones. Because when you get to this next shape, what are our bases now? This is a triangular prism. So I'm going to outline that when I name this. This is going to be a triangle. It's a right triangle, in fact. So I'm going to go ahead and darken that so you can see it a little bit. That's a right triangle. And so I'm going to call this my triangular prism. That's going to come into play in a minute because whenever we do volume, it's area of the base times the height. And we're going to have to find the area of that triangle. Okay, so what is my height between my bases? From the front triangle to the back triangle, there are 5 meters in between those two. So my height is going to be 5 meters, even though it looks like it might be 10. My height is going to be 5 meters. Okay, that's the height, that's the vertical distance between the bases. Okay, so now let's find our area of the base. Well, what shape is the base? Since the base is a triangle, I know that my formula is going to be base times height divided by 2. So I'm going to look at just this shape. What are my base and height of this shape? What is the combo it gives me? With the right angle, you always find the ones that are perpendicular to each other. It has to have that marking. And so that's going to be 10 and 6. So that's going to be 10 times 6 divided by 2. So what is half of 60? That is going to give me a area for that base of 30 meters squared. So it's going to be 30 meters squared. I'm not going to write the units every time, but just to get us used to it. And then what is the height between those two bases? It's going to be 5 meters. So what is 30 times 5? That is going to give me a total volume of 150 meters cubed. 150 meters cubed is my total volume. Okay. Now let's go to this next problem. Now we are back to a rectangular prism. And so my formula is going to be volume equals base times height. Okay. And so we can use any parallel congruent faces as my bases, but I'm going to use these two. And so what is going to be the area of that base? Well, that's going to be a 10 by 12. It's going to give me 120 centimeters squared for my base. What is the height between those two bases? My height between those two bases is going to be 8. So 120 times 8 is going to be my volume. And so when I do 120 times 8, I believe I get 960 centimeters cubed. So that is my volume. All right. Now we get to a little bit harder of a problem. And this is why we always talk about H just doesn't stand for height. It stands for the height between the bases. So what shape are my bases on this prism? These are triangles. So this is going to be a triangular prism. These seem to be the hardest for most people. And so what is my height between those two triangles, the triangle on the bottom to the triangle on the top? The height between those two triangles is going to be 3. So now I've got volume equals base times height. I've got the 3, but I need to find the area of that triangle. So when you go to find the area of that blue triangle, just the blue triangle, I like to circle it to kind of help me focus on it. Oh, need the actual pen. I'm going to circle this. And we've got a lot of pieces that are written on there. We've got 4.3, we've got 8, and we've got 6. So there's technically 3 bases. There's the 8, the 6, and we don't have this one right here written yet, but we can find it. How do we find that base? Well, it's facing the same way as this one, and so it's going to be 11. So I get to add an 11 right here. So I have 3 bases. 11 is a base, 6 is a base, and 8 is a base. But which one has the proper markings to show that it's perpendicular to its corresponding height? That is, here's my right angle. So I've got this piece is perpendicular to this piece. So the base height combo that I'm going to use is the 11 with the 4.3. So that 4.3 is not the height of the figure, 4.3 is the height of that triangle. So that's going to be 11 times 4.3, base times height, divided by 2 because this is a triangle. So when I do that, I'm going to get 11, let's clear that out, 11 times 4.3 divided by 2. So that's going to be 23.75, or 0.65. Okay, so that's the area of my triangle. And then I'm going to multiply that by 3. So that is going to give me exactly 70.95 centimeters cubed. But it wants me to round to my nearest tenth, it says in the directions, so that's going to actually round up to 71 centimeters cubed of volume on this shape. So we do have to round that up. So that was the hardest one we've done so far. All right, we get to this next shape, and this is where y'all start to fly. So what I do love is that Y'all have gotten really, really, really good at finding the volume of these shapes over the years. So what I tried to do, just to kind of make sure you can focus in on it, is put more than information than you need on there. So no longer do we just have a length, width, and a height given like in this picture. I have 5 things written on this picture. I have the 5, the 12, the 10, the 5, and the 12. So it really makes you focus on, well, what do I need? So it's going to be a rectangular prism. The formula for the volume of a prism is base times height. So let's focus on what we need. Pick one of the bases to focus on. I'm going to pick the bottom base, but we know that they're congruent, so it doesn't matter which base you pick. If I pick the bottom base, it's the 12 and a 5, but if I pick the top base, it'd be a 12 and a 5 as well. Okay, so, oh goodness, there we go. So I'm going to work with my bottom base. How do you find the area of this shape? I'm just going to do 12 times 5. Why do I not have to divide by 2? Well, because this is a rectangle, it's not a triangle. And so that's going to be 60 times 10. And so what are going to be, let's see, 60 times 10, so my dimensions are going to be km cubed, and so that's going to be 600 km cubed, kilometers cubed of space. All right, then we get to another triangular prism. So slow down when you get to these. Triangular prism. Because we have to think about the fact that the formula, when it says B, is the area of a triangular base. So I like to color code. That kind of helps me focus on where I need to focus. So there's my 2 bases that are parallel and congruent. Here's my height between those bases. So I have the 10, got that part of the formula in. I just need to find my area of that triangle. So this is going to be a triangle. So because it's a triangle, I have to do base times height divided by 2. Well, here's my right angle that I need. So what's touching that? The 8, the base that is 8. Well, what is the height of that triangle? Be careful here. This picture makes it a little bit hard to see. The height is actually this dotted line. So it's not 10. The 10 is pointing to that solid line. So the 10 is pointing here. What is the yellow line going to be? The yellow line is going to be 6 miles. We get that from the fact that it faces the same way as this one. So I'm going to be working with the 6 and the 8. So that's going to be 6 times 8. That's divided by 2. The area of that triangle, and so 6 times 8 divided by 2 is going to be 24 for the area of that triangle. So then 24, we're going to take that and we're going to multiply that by 3. That is going to give me a total volume of 72. Make sure, yeah, 72. 24 times. Y'all, why did I write a 3? I am so sorry. I was like, this is not big enough. This is going to be 24 times 10. 24 times 10. I'm not sure why I wrote down a 3 or where I even got a 3 from. Okay, so my height between those two, I highlighted it right. I just wrote it down wrong. That is going to be a height of 10. So then that's going to be 24 times 10. So good catch. If you caught that, you stumped Miss Hall. I couldn't figure out why I had written that down. 24 times 10 is going to give me 240. That is going to give me miles cubed. So be careful. It's always going to be in units to the 3rd power for volume. So there's our triangular prism. All right, then we get to our cylinders, and cylinders are way easier because, like we said before, the base is always, always, always a circle. And so we're going to do a few of these. We're not going to do all of them, and we're going to save our word problems to start class tomorrow. You will not have homework tonight. You get to do it in class tomorrow. And so what we're going to do is we're going to say, okay, volume equals base times height. Well, what shape is the base? The base is always going to be a circle. So what can I fill in my formula that I couldn't on the last one? Well, I can fill in this formula for the area of a circle, which is always going to be pi r squared, no matter what. So for all of these cylinders, you can fill in pi r squared h. So my volume is going to be equal to my pi times the radius. Radius is going to be 4 in this picture. So 4 squared times my height, which of course is going to be 8. Actually write down the right thing this time. So when we want to leave this in terms of pi is what it says. So if we wanted to figure out what it is rounded, we could type it all in, but because we want it in terms of pi, we're just going to type this part into my calculator. So you will type in 4 squared times 8. 4 squared times 8. That gives me 128, oh goodness, 128 pi meters cubed of volume. Okay, so that's in terms of pi. If you wanted to know what that is rounded, you could just actually multiply it out. 128 times pi is going to give me about 402 meters cubed of space inside of this can or this cylinder, but it wants it in terms of pi. Sorry, y'all. Okay, so now I'm going to color code this next part. All right, so what is my height between these bases? My height between these bases is 7, and my diameter is 14. Well, we need our radius. Our formula has a radius in it, so our radius is going to be 7 feet. Cross out that 14 when you're done with it so you don't accidentally use it. So when I say that the volume is equal to pi r squared h, I'm going to fill in the correct thing. So that's going to be pi times 7 squared times your height. Well, my height is 7. So that ends up being 7 to the 3rd power, but you can just type it in as 7 squared times 7. That's going to give me 343 pi feet to the 3rd power. Okay. All right, so now we want to actually draw our own cylinder. So it says a cylindrical container. This doesn't have to be perfect. This is just a sketch. So draw 2 circles, connect them. I'm going to go ahead and connect them with the height, but connect them with 2 lines, and it gives us the diameter of 16. Well, I don't need a diameter. I need a radius. So if the diameter is 16, what does that mean the radius is? The radius is going to be half of that, which is going to give me 8 feet. And it says it has a height of 4 feet, so we get to just plug this into our formula. Volume equals base times height, so it's going to be pi times 8 squared times my height, which is 4. So then into my calculator, I just type in 8 squared times 4. That is going to give me 256 pi. I'm going to do this in black so my key matches. 256 pi feet cubed of volume for this shape. Okay, I crossed out the one under it because it's exactly like that, so that was just redundant, so we're just going to skip that one. All right, when you get to this next problem, that's exactly like what we've done before. Here's my height between the bases. Here's my base. It already has the radius I need on it, so we're going to skip that one. If you want to try that one just for funsies, you would get 63 pi yards cubed. I want to move on to this problem because this cylinder is laid on its side. So when you first glance at this, you might want to say that the height is 10. Well, the diameter of the circle is 10, but the height between the 2 bases from the circle on the left to the circle on the right is actually going to be 9. So be careful on this problem. And your radius is going to be half of 10. Well, what is half of 10? That's going to give me 5 feet. Cross him out so he doesn't distract you anymore. And so what is my volume going to be? Volume is going to be equal to base times height. Since it's a circle, that's always going to be pi r squared times height. And so I end up plugging in pi times 5 squared times my height, which is going to be 9. And I type in 5 squared times 9 into my calculator. That is going to give me 225 pi feet cubed. So that is my volume. All right, and so we're going to stop there for today. We're going to start with the other problems tomorrow, so I can add a video tomorrow if I need to. It talks about an aquarium and a pool, and then y'all are going to get to actually work on your assignment, which is on the back, in class tomorrow. So no homework. It'll be a happy Friday. We'll get that done, and y'all can work together to make sure we have this down before we move on to the volume of cones and pyramids. Hope you're having a great day.